Okay, just want us to ensure the meeting is being recorded. Um, Kindly, good morning, ladies. I hope you are doing fine. Please pardon me for yesterday. I was traveling, so we couldn't have a meeting. Yet it is quite important that we have this as a makeup, so that we get to have this concept. And as you attend a class, please ask necessary questions. At least you being in class with a bit of understanding. I think the lecturer is the best person to point you to the area of concentration, because for a lot of reasons they are the ones that had to prepare those assessments and exams. And here we will try by all means looking at these from practical point of view. As you are learning this concept in class, in theory, they will tell you, okay, this is what happens, this is what happens, this is what happens. When you do this, this is what happens. However, at least we're going to have at least a bit understanding of the actual database. What actually happens if this is the case, and we hope to getting back on campus. I think we are going to have a bit of break. Okay, we are going to have a bit of break during the exam period, and for some reasons, instead of abandoning classes completely or meetings completely, we're gonna have a bit of revision, okay, with regards to what we did. Okay, if for example you're writing math the other day, we have math at least for 2 days, okay, so that we get to just revise these concepts together. If you're doing if you are writing, for example, what's this, architecture, we get to have the general overview of these concepts. And depending on whether we are going to agree or not, these meetings will be a cover up for what we were supposed to do for this semester. That's if we're gonna agree. We'll have a comprehensive talk about that within the group, and we'll request everybody to basically participate in that. Okay, so with that being said, good morning once again, and welcome to this morning session. I think we do have our mind fresh. I just want to make sure that you guys get to confirm, supposing my screen is visible and my audio is clear as well, before we proceed with our meeting. Please confirm. Okay, thank you. So this is the second topic. Yeah, this is the second topic. Last, I think with us, we covered about 6 topics with Dr. Zipani himself. um, the your immediate seniors covered about 7 topics. We really are not sure of how many topics you are going to cover, but we will try by all means looking at this from practical point of view. I think for the first 3 topics we are going to do to have purely theory. Then moving to 4th topic, once we have that, then we are ready looking at the actual database. How do we create database? How do we create the table? How do we populate? How do we do the joins? How do we query? How do we update? How do we do this? It's a skill that you need to have by all means necessary. That's very important. So with that being said, welcome to CSC 2702. Okay, the first number here is your year. Okay, the last one is the semester. So this is semester 2. So since they started teaching this, this is 70th time they are doing this. So that is the second and the third number. Basically, that is going to be different in your final year. It means something else as well. Nonetheless, yeah. So database concept and architecture. Okay. So the overview, so the growth in data storage needs has led to development of distributed database system. We are going to look at that concept at a later stage. Okay. So how do we explain this? So how do we explain this? We are basically saying the growth of data storage. I always try by all means giving an example of a clinic or a hospital. Once it is just opened for the first time, we basically do not have no record for any patient because this clinic was just under construction. So the only papers are there are basically papers to do with construction, the information of how much was spent, the phases, the workers, the payment, and so on and so forth. So that clinic or hospital has no record for whatsoever patient at that particular time. Okay, give me a minute. Okay, please pardon me for that. So, like we were saying, this clinic or hospital has no record of any patient. So when it is opened now, someone will go there and say, I'm feeling fatigue, I'm having headache, okay, I'm having difficulties in terms of sleeping. That is one of a symptom of insomnia, okay. Basically, I'm eating too much. I'm having difficulties when it comes to eating. They will give you either stimulators or suppressors depending on what you are feeling. Okay, I need that. All those records are kept at that facility. So as time goes on, there will be growth in data storage. Okay, there will be growth in data storage. Like the University of Zambia, it sees that okay, Great East Road cannot keep the records of everyone. They'll basically say, okay, why can't we have another campus at Ridgeway? Why can't we have another campus, for example, in the Copper Belt? So the growth in data storage needs has led to development of distributed database system. So what we are saying is, basically with the banks, that is the best way of looking at it. A bank has a branch in almost every major city: Lusaka, Kawe, Ndola, Kapiri, Kitwe, Luansha, Chingola, Mufurira, Mufulira, and so on and so forth. So all these the update to the data in one branch will reflect in all other branches. That's what we are saying, distributed database system. So they operate across thousands of computers. That's what we're basically saying. Okay, they have 100 computers in Lusaka, 100 computers in Copperbelt, 100 computers in Livingston, and so forth, and so on and so forth. So this will align with the shift from centralized, okay, from the central way of doing things to networked stations and server. What we are saying is, instead of doing all these in a central place, we are going to ensure that these computers communicate via network, so that the update to one computer is reflected to all other computers, because they are able to communicate via the network. That's what we're saying there. Okay, so modern database management system. Remember, this is a software environment, particularly in cloud computing. Especially you guys in networking, you are going to have this course with your professor, Piri, called cloud computing. There consists of thousands of servers. Okay, managing large-scale data. Large-scale data is also called big data for user over the web. Okay. Okay. Basically, there is a very nice definition for a server, but I don't think this is the right time for us to discuss that. So we'll give you basic definition of a server. So we're gonna look at essential database concepts. Okay, these database concepts: data model, schema, instance, schema, 3 schema architecture. We're gonna look at that. We also look at an overview of a database management system interface, languages and system software environment, various client-server architectures, and classification of database management system types. And now we venture into what we have to look at: data models, schemas, and instances. Before we actually start, are we together up to this point? Okay, thank you. There's a very nice diagram that we are going to look at in terms of data abstraction that we're gonna look at that. So the database approach emphasizes data abstraction, allowing users to view data at varying levels of detail by suppressing the complexity of data organization and storage. Don't bother about this. We will explain. There's a very nice diagram ahead. We will come back to this. So data model. Okay. So data model is at the center. Okay. To achieving data abstraction. Data abstraction, maybe to just try and say something there, we are saying okay, just to try and say something, let me do this. Okay, so data abstraction, we are just saying securing this data. Okay, putting some level of security so that you don't easily manipulate that data. So we are putting this data in different layers. So there is layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, layer 7, layer 8, layer 9, and so on and so forth. So if you are at layer 10, okay, you have to come to layer 9, layer 8, layer 7, layer 6, layer 5, layer 4, layer 3, layer 2. Okay, mama. Sabwelo on. Okay. Basically, please pardon me for that. I was on a copper belt for some time. Just got back to Kawe as of yesterday. Okay. So if data itself is put on layer 1 and you are on layer 10, so this data cannot be directly accessed. For you to access that data, it's more like you have rooms in the house and each room has the door. Okay, if you have to move from kitchen to a living room or to a TV room, okay, for those of you guys who have a TV room and a sitting room, okay, we grew up in the environment where the TV room was also a sitting room. Okay, so you have a TV room. For you to access a TV room, you have to unlock the door to the dining, or maybe the door to the passage. From the passage to the TV room, you have to also unlock the door. So a TV is somewhat prevented from you, okay, from being directly accessed. So what we are just saying is data abstraction, we put some level of protection, okay, to access this data. This data cannot be directly accessed. Instead, you have to go through phases. It is hidden from you. Okay, so data abstraction is basically data hiding. Okay, that's what we are saying. We are saying there. So the database approach emphasizes data hiding. That's very important. Allowing users to view data at varying, okay, or different levels of detail by suppressing, that is hiding the complexity of data and organization and storage there. So data model is at center of achieving data abstraction. Very important. This defines the structure of database, which includes data types, relationships, constraints, as well as providing basic operations for data retrieval and updates. So maybe we go just through these one by one. So data model is central to achieving data hiding or abstraction. This defines the structure of this database. So data abstraction defines the structure of the database, and the database will include, okay, concept or to do of the following. Okay, data types. We looked at data types last time. Is it int? Is it variable character? Is it decimal? And so on and so forth. Okay, relationships. Basically, I don't know if it's with you guys, but let me ask: did we at any point try to discuss the concept of keys, primary key, foreign key? Did we? Okay, it means not you. Right. Think they're your seniors. Okay, relationships. So we are going to talk about what brings two tables together. Okay, those are relationships. For example, the foreign key. What brings two families together? Okay, they are basically a guy and a girl who at some point were foreigners to each other. They never knew each other. So they meet, they like each other. Basically, now they say, okay, we are not strangers no more. At this point, I think it's quite important we get to be known to both families. So from strangers to being known. So we're gonna look at that concept, how that brings about relationships. Okay, constraints. Constraints are basically rules that are going to be applied on this database, as well as providing the basic operations for data retrieval. Basically, how we're going to retrieve or get that data, or updates. Okay, how we're going to make changes. So modern data model increasingly includes a concept to specify dynamic behavior of database application, allowing user-defined operations specific to data objects. We're gonna look at this at a later stage. Okay, a user-defined operation like compute GPA for a student, and so on and so forth. What we are basically saying is there are terms that we are going to look at. Okay, for example, the database name. If we say create database, what is the database name for that? Dimanda? Gena? Oh, hapo. Okay, so that is quite important, right? Please pardon me for that. So we're gonna look at all those concepts all together. Okay, student objects. This complements the basic operations of data model. We're gonna look at insert. Okay, what do we mean by insert? What do we mean by delete? What do we mean by modify? What do we mean by retrieve? By adding functionality specific to certain data objects. Please don't bother about what insert mean. what delete means. Obviously we can delete, we can relate what delete is: removing what you need to remove completely. Modify is making changes, retrieving and all that. Please, just for now, don't bother about that. Okay, so categories of data model. Okay, we have what we are calling conceptual. Okay, it's just a concept. Just forget about UAL. When you have this is just concept. Okay, from there to basically there. So this is just a concept. Okay, so conceptual is just if you have a concept, it means you have an idea. Okay, you are thinking about you are basically thinking about something, and is what you are thinking about possible? Okay, so is what you are thinking about possible? That is conceptual. So you just have an idea of what is going on, or what you are going to do. So this is high level. Okay, and whenever you talk about your high level, remember, from your programming point of view, this is basically saying close to, or if anything, exactly to a day-to-day language. Okay, and this is basically in English most of the time. So you're looking at data in terms of a high level data model. You can describe basically in English in most cases. So this provides concepts that are close to the way many users perceive or see data. So it just provides the concepts that are close to the way many users perceive or look at data. That's the high level. Okay, and that high level model will include things like that entity relationship model. Okay, we're gonna look at this at a later stage. Please don't bother for now. Okay, so entity relationship, we'll look at what an entity is at a later stage. We'll look at attributes. We'll look at all those. Then this will come to be alive. But high level, if they ask you to give examples of high level data model, is basically entity relationship model. Okay, and this model in a lot of cases is replaced with the diagram. So we're gonna look at we use concepts like entities, attributes, relationships to represent data in a way that align with how users see the real world. Please, for now, don't bother about what an entity is. I think we are going to cover this in lot more detail in our programming. Attributes. We are just basically saying an entity is a real world object. For example, there are you guys in this meeting. You are entities. Attributes are basically those concepts that gives more details about you. Okay, you are a person. What details, or what are some of things that makes you being identified more easily? One of them is height. Okay, the color of clothes that you like wearing, the color of your eyes, and so on and so forth. Those are attributes. Relationships and basically quite a lot. Okay, there is also low level. When we talk about low level, we now talk about the physical. Okay, the actual, okay, so the actual way of looking at the database. This is just the idea. Okay, you just have a conceptual, just gives us idea. Okay, so how can I describe the database? Then you begin thinking, oh, it is made of tables. In that tables there are columns, there are also rows. In that rows there are data, there are keys, there are this, there are that. You are just explaining. Okay, but how exactly is that in real terms? That is what we are calling low level. Okay, so provide concepts that describe details of how data is stored on a computer. Okay, so you just know that your pictures are stored on your phone, but how exactly are those pictures stored? In what form? Okay, is it in binary, is it in hexadecimal, and so on and so forth. Okay, typically magnetic disk are basically meant for computer specialists, so only a person who is specialized in this will be able to actually describe. Okay, so when a picture is sent in a phone, that picture is converted to blah blah blah, then it is stored like this dot whatever. Then there's a magnetic disk where it is stored specifically at this point. Okay, they can get even a magnetic disk, dismantle it, and basically tell you, okay, this is now what is responsible for storing that, and that is at a low level. Okay, the three is representational. Okay, remember we are talking about categories of data model: high level, low level, and representational, also self-describing. And okay, let us look at all these. So representational, okay, representational, we are just now saying how just like high level. Now at this point we are trying to explain for just purely people use. Okay, so providing concepts that may easily understood by end users, but that are not too different from the way data is organized in the computer. So this is basically you explaining to someone who is just interested in using. Okay, that's what we're saying. Frequently used in commercial database management system, those models balance user understanding with how data is organized on storage media, mostly using record structure. So at this point, we are just basically saying we can use the diagram explaining to somebody who is just interested in using. Examples are relational model. Okay, we're gonna look at what a relational model is. When we talk about relational model, we are talking about tables. That's why I did mention of a drawing, and we are going to look at that at a later stage, as well as old models such as network or hierarchy. Okay, object data model is higher level. Okay, basically we are not saying it's purely higher level, but this is close enough to conceptual. This is close enough to conceptual. And remember, your conceptual here is high level. Category number 4, we are saying in this model, data storage combines data description with the data value themselves. So self-describing, we're just saying we combine how we can describe that data and data themselves. Okay, we're gonna look at this at a later stage. We are talking about things like NoSQL. Okay, NoSQL means not only structured query language. We're gonna look at this concept at a later stage. Okay, let me ask, are we good so far? Any question? If we are good, right. So data schema describes the database, description of database. Basically, let me make mention before we jump to description. Schema means description. I want you to always remember that. Schema means description. So when we say database schema, so we are saying the description of database schema. So you start from here. This is the description. Schema means description. So this is the description of database. That is basically nothing more, nothing less. So when we say description, this is a schema of a database. We are saying database schema. So the description of a schema is called database schema. Okay? Sometimes they can ask you, define database schema. Just remember, schema is description. So this is description of a database. Okay? And is defined during design phase. Okay? It is not expected to change frequently, but it can change. That's the database schema. Schema diagram is also the description of the diagram. And schema diagram is visually presents a certain aspect of a schema, which is a description, such as names of records types and so on and so forth, which we are going to look at a later stage. Okay, so each object within a schema, like student, an object is a real-world entity. Okay. Student is an object, course is an object, okay, because it exists. So each object within a schema, like student or course, is referred to as schema construct. Constraint is basically a rule, okay, some constraints or some rules, like complex rules for data relationships or conditions, are difficult to represent in schema diagram. We're gonna look at this at a later stage. Okay, database schema, description of a database. Example, we have this. So this table of a student is what we are calling a schema, relation schema or schema diagram. Okay, so what we are basically saying, there's a relation. Okay, so the whole thing, this name and the table, is a relation schema. Okay, then this is a relation name. So when we talk about a relation, we are talking about the whole thing, the combination of a name and the table itself. This is a relation, and this name is a relation name. Okay, so student is the name of this relation. Then there's a table with the column. Okay, I think we can talk about this concept. Which concept is that? Let me make remind you. Which concept? Which concept? Key, which concept is that? Okay, these two. I think we can talk about these two. I think we can talk about entity attributes. Okay, I think we can talk about these now. Question: does a student exist? Does a student exist?
Yes.
Good. Yes. Exactly. Yes. So, a student, since this exists in a real world, this is what we're calling an entity. It's an object that exists in the real world. Okay, so that is an entity. Then, this student has a name. This student has a student number. This student belongs to a class, and this student has a major. For example, at Tunza you can be a networking major, a system major, or a software major. Okay, you can major in physics and all that. So you would find that you would realize that the name, when you just say student, we do not have much information about this student. But the moment we know the name of this student, this name gives more information about this student. Okay, what is their student ID? Gives more information about this student. The class they belong, okay, the major. These all gives more information about this student. True or false?
True.
Exactly. So these, okay, these guys which gives more information about this entity are what we are calling attributes. That's very important. Same applies. Please go ahead.
So, meaning you can say attributes give more information
About an entity.
about an entity. Then the entity, how best can you describe one entity?
An object that exists in the real world. Exactly. Do you exist in the real world?
Yes.
Exactly. So you are an entity. Do you have a name?
Yes.
Obvious. Does that name give more information about you?
Yes.
Exactly. So that is an attribute. I hope that helps.
Yes.
Exactly. Basically, that is in all this table. We are just explaining those concepts. So the section, there is grade report. Basically, when it comes to secondary schools, we have report books. Those report books exist in the real world. Okay, it will show the grades. The grades gives more information about that report. Okay, that is basically what we are saying. Database schema is just a description of the database. The schema and constraints. Constraints are rules as stored in database management system catalog. Okay, so this is a software. Remember, let me re-ask this. What is DBMS? I think we looked at that. Unless we didn't, define the DBMS for us. Please just unmute yourself. Do I have people? Yes. Please define DBMS for us. No one is defining for us? Okay, Lissy? Sure, sure. We appreciate your try. Lissy, please also say something. Give me a, give me a minute. Give me a minute. Okay, please go ahead. Okay, thank you. Okay, so sadly, you are not far from that, except for it is a software like Lee said. So this is a software, okay? So there is you as a user. Now you as a user have to create and maintain the database, okay? You have to create and maintain the database. But that will not be possible without this software. So it's just a software that makes or enables a user to create and maintain database, just like so all those create, manage, retrieve, and the like, all those terms comes into manage and create, except for what you said at first, because you didn't say software. If you can say software, you can also say a tool. Okay, Tool, a tool. So the schema and constraints are stored in database management system catalog as metadata. Okay, we're gonna look at metadata at a later stage. Right, so that's what we are basically saying. Database instance and schema there. Okay, please pardon me for that. Database instances and states. So the actual data, an instance. Let's just explain these from these. So an instance, okay, is the actual data in the database. So database instance is the actual data in the database. So the actual data in a database at a specific time is called database state. Okay? Now, please differentiate the two. The actual data in the database is what we are calling the instance. Okay? Instance. Let me color this with a different. So, the instance is the actual data in the database. Okay? But the actual data in the database at a specific time is the database state. When you add specific time or moment, this become database state. But if you haven't added specific moment, you just say actual data in the database, is database instance. Instance changes frequently as new data is added or updated. Schema versus state. Okay. Schema is a description. Remember, state is the data at a specific moment. So the database schema defines the structure of the database, while database state refer to the current data held in the database at a given time. Initial state of database occur when it is first populated. So the first time you are putting that data in the database is what we are calling the initial state. And the current state of a database at any moment after that putting. So database management system ensures that every database state is valid. That's another function of this guy. Besides making you create and manage, it also ensures that database state is valid. Okay, how does it ensure? By sticking or adhering to 1, the structure, which is a schema, and the constraints, which are rules defined in that schema or a structure. So there are three schema architecture. One of them is what we call internal. The second is conceptual. The third is external. So internal just deal with the storage. Okay, this is more like low level, which we looked at some point. So internal structure, basically now we are talking about 3 schema architecture. Okay, architecture is basically the design. So when we say schema, 3 schema, it's a 3 description. How do we describe that design now? That's architecture. Remember your architecture? Architecture is design in relation to functionality. Remember your architecture. So the 3 schema architecture separates the user application from physical database by defining schema at 3 different levels. There is what we call internal, conceptual, and external. So internal now just talks about how this data is stored physically. Okay, that's what we're saying. Conceptual just gives you that idea. Now it's just the concept. Okay, so conceptual schema represents the entire database structure for all users, focusing on entities, relationships, constraints, while hiding details of a physical storage. In a nutshell, this is how we are just looking at this database ideally. Okay, external, now this is more like high level. Okay, external or view level consists of multiple external schemas, each tailored to the needs of specific user groups, representing only the relevant part of a database, hiding the rest. So what we're just saying is we just get what we are interested at this point. Okay, this just explains more of what we are looking at there. So this is we can explain this. I think now we can explain, not in this diagram, okay, but we can explain So this is what happens in 3-schema architecture. So there is a user here. You want to use data, but this database is basically stored physically here. So this is low level or internal. Okay, so this is low level, okay, which is internal schema. Describes how the data is physically stored on the physical media, which is internal level. Okay, so there is a user here. Now, for you as a user, what you are interacting with the application, and this is on external view. So, external level, there's a conceptual level. You just have an idea of saying there is data somewhere. Okay, there's a data somewhere, but that's not exactly what it is. So this gives you an idea. So for you to access this data, now you have to go through the internal schema. Then this data, you go like that, you come like that, then you come here. Then you get that data, gets to the conceptual until it comes to external view. Now, that connection between the external and conceptual is what we are calling external conceptual mapping. And that connection between conceptual and internal is what we are calling conceptual internal mapping. Mapping is just a relationship. And this explains data abstraction. So there is database here, storing the actual database. But you are here, so you can't see what is happening here. That means this data in this database is hidden from you as a user. So that hiding, that is suppressing, okay, that because the complexity here is hidden, is what we are calling data abstraction. I hope you are fine there. Okay, data independence. Okay, data independence. Do we have another diagram? Let's see. I think we can use that very one. Okay, we don't have. We can use this very one. Data independence is just a concept which states that just a concept which states that making changes to external view, those changes does not affect conceptual view. So when you make changes here, those changes does not affect how data is viewed at this point. When you make changes here, those changes does not affect how data is stored here. Okay, so change to one view does not affect the other. That is data independence. When we say we are independent, we are a sovereign state, what we are saying is when America makes a decision, those decisions does not affect Zambia directly. So this is what we are saying. Data independence refer to the ability to change the schema at one level of a database system without affecting the schema at next higher level, ensuring stability in user application and external view. So when you make changes here, those changes does not affect this, does not affect that as well. That is very very important. So those changes can be logical data independence or physical data independence. So logical data independence, this logical, it's more like concept. Okay, allow changes to conceptual. So logical is concept. Okay, so physical, this is now at low level. So these two, what we are saying, when you make changes here, those changes are logical. Those changes will not affect how data is viewed here. When you talk about physical is making changes here, those changes does not affect conceptual, does not also affect external. That's what we are saying there. So how do we achieve data independence? It's quite challenging. That's what we are saying there. Are we together up to this point? Or you guys have a question? Good. It's quite challenging, okay, to achieve that independence, especially at a logical point of view. At physical point of view is quite easy, which we are going to see at a later stage. So mapping between different schema level as stored in catalog. So software languages or DBMS languages, basically we have those languages. One of them is data definition, DDL. The other one is storage definition, SDL, view definition, VDL, and data manipulating DML. Of these, I think we are going to concentrate much on fourth. Of course, don't forget the first. So the DDL, data definition language, this just defines the data types, okay, used by database administrator and designers to define both a conceptual and internal with each description stored in that catalog. So what we are just saying is, this is when we are creating the database, we are specifying the data types that we are going to be using. Are we looking at numbers? Are we looking at letters? Okay, are we looking at money, and so on and so forth, which we are going to look at later stage. Storage definition language just to specify how that database now which we created here, how it is going to be stored. View definition, okay, just describe how that data is going to be represented to you. Then data manipulation, now how do we get this data? How are we going to delete? How are we going to update? How are we going to do all these making changes and so on and so forth? So this is through retrieval, insertion, deletion, modification. We're gonna look at this at a later stage. Did we lose anyone? Did we lose anyone? This?
Yes.
Okay. Data manipulation just talks about how are we going to make changes to this data in the form of retrieval, getting, insertion, putting, deletion, removing, modification, making changes. That's what data manipulation language is. There are 4 languages for this software. Okay, so this just explains now data manipulation language, which is this guy. If you remember, I said I think we're gonna talk about this guy more. Data manipulation language. Basically, it is of both high-level data manipulation language and low-level data manipulation language. Okay. User-friendly interfaces available for those who prefer not to learn the detail of query language. Not so important. The interfaces are quite a few. Okay, an interface is basically the way that we are interacting or interfacing or interacting or facing each other, like how this application and us are helping each other. For example, I'm using the cursor, but this cursor is not on this screen by accident. I have played a role, and the application itself has played a role. So that dual way of working on this or looking at this is what we are calling interface. Okay. Um, in real world, there's a man, there's a woman. So between these two people, there are those guys they call matrons and patrons. This one will move from a guy going to a woman's family, talking to them about how serious this guy is. From a woman's side, a matron will move, getting to there. So that communication is managed by between the guy and a guy's family and a girl's family. Those communication are managed by some type of people. So this is the same thing that we are trying to achieve. So interface is basically how the application and the user are talking to one another. They are not talking to one another directly. So there are some type of software in which a user sends the information to an application, then application responds back. So there is this guy who is transmitting this information in between. Okay. Again, in the real world, we can look at this in terms of Lusaka Intercity, and if you've been to Livingston or Copperbelt, basically these two have stations. So a bus will basically facilitate how you is going to move from one point to another. Or you can be in Lusaka, wants to send a parcel to Copperbelt. Basically, we are saying the bus becomes an interface, okay, or the means by which that parcel is going to move from person A in this location to person B in that location, and vice versa. That's what we are calling an interface. Okay, so there are quite a few. They are menu based. Okay, a menu based, like you can see here. I can have this. Okay, I can have this, I can have that, 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 I can have that. So there are those options that are in that screen. That is what we are calling menu based. So guides the user through queries by presenting options in step-by-step manner via menus, commonly used in web client. Okay, there is also mobile app interface. This is when you are using that mobile device. There is also a form based. A form will be presented to you to fill in. Okay, so this allows users to input or retrieve data by filling out forms. Okay, basically lots of times this is going to be some form of transaction. There is also graphical, okay, user interface, GUI. So represents database schema in diagrammatic manner. Okay, a lot more. There is also natural language interface. Okay, representing the natural language interpreting. So what we are just saying is a Chinese guy come. So there is a person in Zambia who understands Chinese, who understands Zambian language. They can speak, they can interpret that to you. That is what we are calling natural language interface. Okay, and in web development, in web development, basically, there's what we are calling. Okay, let me not bombard you with a lot of information. You learn that next year. So there is also keyboard-based search. Okay, so allow users to search databases using natural language keyword. Okay, you type in from your keyboard. You just say S, and this S will give you a lot of results. Are you looking at SIS, a student information system? Are you looking at whatever you're looking at? So you are going to choose based on that. There is also a speech input and output. A good example is Siri, Google. Google is, I think, has some form of speech input and output. Okay, you tell it, hi Google, please call this one for me. It will basically will. Okay, so enable limited voice interaction for querying and retrieving database responses. Use it in applications like dictionary inquiry or filing information system. There is also parametric. These are type of users, DBA interface, and so on and so forth. You can't basically know all of them. Okay, so database management system components. Please, I want to point you out to this. I want you to pay particular attention. So the components of this software is divided into user interface and internal module. A module is a part. So when we say module, we're just saying a part. So component, parts. So this is a main division. A component is main division. So within this division there are parts. So what we are saying is there is this component here. There's a clear line there. So there is this component here. So within this component there are modules. So this is a module, this is a module, this is a module, this is a module. Okay, there is also this module. I mean, there's this also component. This is a module, this is a module, and the like. So it is divided into two. This guy divided into two components, and these components have parts. So what happens is like this. So there are users here. You as a user, you are a database administrator. So this database administrator or DBA is a staff. Okay, there is casual user, there are programmers, there are also parametric users. Okay. Basically, this is in types of users. When you read the first meeting that we had last time, there are types of users, types of end users. We have parametric users, casual users, and a lot more. I think there are about 4, only that I don't have them now. So what happens is this: database administrator is a staff. So this is staff makes statements in form of DDL, data definition language. Okay. Then this data definition language will make the statements, and those statements are going to be compiled, right? Then this is staff, which as an administrator gives privileges. Okay, allows who going to have an access at what time. There's a casual user. This just interactive queries. Okay, those queries basically is just a form of asking for a type of data which you need from the database. That is querying. Now those queries are going to be compiled by compiler, okay, and they are going to be optimized by query optimizer. Application programmers, basically this make those applications which have to be pre-compiled, DML, okay, data manipulation language, compiler there, okay. Now there is a host here which going to compile those transactions. Okay, so when this happens, they have a meeting point. This meeting point now is what we are calling. Remember, there is DBA here, database administrator. There are commands. There are commands here. There are querying here. There are programs here. There are transactions there, and so on and so forth. Basically, this meeting point is what we are calling DBA commands, queries, and transactions point. Okay, so this is where the commands from this guy, querying and transactions are meeting. Why do we have 3 here? Very important. So we have DBA commands, and this is what we have here. So what is coming from this side are commands from DBA. That's why you have DBA commands. Then from here, what is coming here are queries. Query. These queries come there. You don't have from application. From the point of application, you don't have anything coming there. Okay. From here, you don't have that. What you have is that. So is transactions there, and this is the point. Okay. Then there is this component. Once these statements, okay, once these statements are made, now they have to be stored somewhere. So this is a system catalog or data dictionary. Remember, you are making statements which are compiled. These statements are going to act as a dictionary in this system. Right, now these guys, they have to be processed. Okay, so we have runtime database processor. Okay, then they have to be stored by some of management. Then there is a physical storage there. Okay, so there is concurrence control, backup recovery, and recovery some subsystem. So once these guys are now processed, they have to be stored, but you need to have some form of backup which have to be managed. Okay, so if this fails, we have some form of backup. It has to come here, being processed, basically sent there. Once sent there, these now can be sent back like that. So this is this internal component. This is some external component or user interface, which is the user here. So when you read those, basically just explains this diagram. That's what is going on. No one will ask you this, but it's just important to understand for the sake of what we're going to be doing in practice. Quite important. Are we good? Give me a thumbs up.
Yes, sir.
Good. Thank you. Component modules. This now just explains database administrator, which is a staff, works with the DDL. Casual user works with interactive query, and this is basically what we're explaining. Casual user works with interactive query. Database staff works with DDL statements, and so on and so forth. So these just explain. Application programmer writes application, which we explained. Parametric users do data entry. Application programs are compiled by compiler, and so on and so forth. All these just explains what we are talking about in that diagram. So that database system utilities, okay. Do we remember what a database system is? Do we remember what a database system is? Do we? Please unmute yourselves. Do we remember what a database system is? Not what is database, but database system. Database system. Database system. I hope you can see. I hope we can see. No, I'm in a meeting. I hope we can see.
Yeah.
This is from the first lecture we had. I hope you guys have been reading. Database and its software database system. Hope we don't forget. Okay, that's the database system utility. Now we are talking about database and its software. Okay, This helps help manage the database system. Okay, utilities help manage database system. So there is loading, there is backup, there is storage recognition or reorganization. There is storage reorganization and performance history. Okay, so loading used to load existing data. Backup just creates backup. I think at this point is it's not a debate. When we talk about backup, we are basically talking about creating a separate storage to which we can transfer the same data. In an event the storage we're working with get lost, we can get a different storage and replace that data. And that's where external hard drive, flash drives are important. Unfortunately, I lost mine. I lost my external hard drive, which is quite bad. Okay, storage reorganization reorganizes data file into different organization and creates new access path. Performance monitoring just provides statistics and help decide on actions like the index management. Basically, I think you can just know for utilities. They can ask you what are the 4 database system utilities: loading, backup, and the like. Okay, so I think during our time they did ask us the additional utilities. They didn't ask us the actual utilities. So the sorting, handling, compression. Basically, you can compress data, monitoring, and interfacing. They did ask us 4 of them: sorting, compression, monitoring, and interfacing, without explaining them. Okay, centralizing DBMS architecture is just working with a database in a central place. So this occurs on a single machine. So you have your own PC without using another person's PC. So all functionalities, execution of those applications, and user interface processing occurs on a single machine, maintaining a central place. So this actually handles all system functionalities. Not much to explain there. So this is actually what happens there. Okay, so there is computer 1, computer 2, blah 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 blah, and computer whatever that computer is. Then these computers are communicating on a network using a switch. So there are these applications there. So application program, terminal control, and the like. And these guys, these applications there, which are managed by a single software. Okay. Then there's an operating system which is managing the interaction of this software, and that. And the system bus there. There's a CPU, there's memory, there's disk, and all these have some form of way of interaction on the hardware. That's what we're saying here. Not so important. I'll keep emphasizing. basic client server. Let's see. Okay. The way the way you have to look at this is, please pardon me. The way you have to look at this, we'll finish in a moment. The way you have to look at this is, there are two people. Okay. And again, I like using this funny example of a guy and a girl. So a guy approached a girl, you know, they start their fantasy, which will translate in reality depending on how serious they get things. The guy approached a girl. You know what? Then a girl say, okay, let me think about it. Then a girl at a later stage, based on her analysis and availability of the other gender, will come and say, okay, you know what? I thought about it. I'm not interested. Or I think we can give it a try. So these two people, a guy made a proposal. So this guy who is making a proposal is what we are calling, please pardon me, thinking deals and okay, please pardon me for that. So example was using. So a guy made a proposal. Then a girl gives a response. This is the same way with the client-server architecture. Okay. So there are two computers. Okay. So one computer will initiate a request. Okay. So a client is a computing process, a computing resource that initiates a request and processes the response. What we are saying is a client is basically a computer, okay, which initiates or starts a request. So there is you. You go on Google, then you say, okay, I want to download this movie. Then you type in Google a movie. So your computer starts that request, makes a proposal. That proposal will not be processed on your computer. So there's a computer somewhere which has the information that you are looking for. Then that computer somewhere which has the information you are looking for brings that information back to you. That is a server. So a server is basically a computing resource that listens to or listens for the incoming request. So there is an incoming request. That's what you do. Someone will request, then you listen. What are they going to request? Okay. Then you process that request. That computing resource processes that request and gives a feedback. Okay, that is a client server. A client makes a request. A server brings the response. I hope that that explanation is okay. Kindly give me a thumbs up. Do we have people in the meeting? I know it's quite a long meeting. Do we have people in here? Hello?
Yes.
Okay, good. Please just take time to do that. So there are two main types of DBMS architecture. We have two-tier architecture. Two-tier is what we are saying. There's a client, there's a server, and these guys are interacting in the network. Okay, so this initiates the request, then this gives the feedback via a network. So this is a two-tier. Okay, there is also a three-tier. A two-tier is just a client server. So that is what is happening. This is what is happening there. Okay. Two-tier there. There is also what we are calling three-tier. Okay. So in this case, also what we are calling n-tier. Okay. So three-tier, we are just basically saying there's a client, there are two servers. N-tier, there is a client, there are more than two servers. That is n-tier. Okay. So client there are applications, web servers, there is database. So this is a three-tier. 1, 2, 3. So client, server, database. Three-tier. You're not so important. You can just read that through. Cost classification, not so important. Just read through that. No one will examine you on that. Basically, we've come to just an end to that. Unless you guys have a question. Do we have a question? Okay, good. We end here. We see each other next week. Next week we'll have the full discussion Monday, Wednesday, and Friday. Maybe Friday we can compromise depending on what you guys are going to write first. We can compromise on Friday so that we bring in those revisions, and those revisions, depending on how we can agree, are going to be part. That means we are not going to have makeups for what we are not going to do. Instead, we're gonna do that. We'll bring that discussion in the group. Look out for that. Okay, thank you. Thank you. I appreciate that.